mixing with new genetically different populations.
So we just finished talking about Mendel and about Darwin, and how it's going to explain how they're connected.
Now that you know all that, in order to explain specifically how these processes influence populations, we're going to have to completely forget about them. This is what's called the Hardy-Weinberg principle. Godfrey Hardy and Wilhelm Weinberg were two scientists in 1908 who independently, at the same time, came up with the exact same equation that describes how, under the right circumstances, Mendelian genetics works at the scale of a whole population. But those right circumstances assume that none of the factors I just mentioned are at play. Hardy and Weinberg's simple equation shows us the frequency with which you could expect to find different alleles within a hypothetical population that's not evolving. This weird hypothetical state is called the Hardy-Weinberg equilibrium, in which the frequency of alleles in a population remains constant from generation to generation. And to make sure that happens, no funny stuff is allowed to go on. To wit, the Hardy-Weinberg equilibrium requires no natural selection, which means that no alleles are more beneficial than any other, so the better alleles will not be selected within a population. No sexual selection, which means that mating within the population must be completely random. No individual can have a better chance of getting it on than any other. No mutations, because mutations modify the gene pool. Hardy-Weinberg demands a gigantic population size because the smaller the population, the more likely you are to get genetic drift. And finally, no gene flow. That means that nobody can bring over their hot cousin from the next island over, because that would significantly mess with the allele frequencies. You know what I mean. So clearly, no fun and lots of rules. Hardy and Weinberg